Good morning, students. Well, in the previous class, I had discussed about the galvanic shell. That is an example of the electrochemical cell, and EMF of the cell, electrode, standard electrode potential, and the term calculation of EMF of the cell, electromotive force, how it will be calculated, and there are three different conditions. Up to that, and the electrochemical series. And what is the electrochemical series and the standard electrode potential? Electrochemical series plays a vital role in the organic chemistry. It tells about the reactivity of the metals. It tells which will act as a oxidizing agent, which will be reducing agent. It tells about the feasibility of the reaction. Just as for example, if we consider zinc rod is placed in a copper sulfate solution, then zinc is more reactive because its reduction potential value is very high. So zinc displaces copper from copper sulfate solution. But if we take the zinc sulfate solution and put the copper rod, the reaction does not happen. So for that, we calculate the E0 cell. E0 cell when the concentration of zinc and the copper sulfate solutions are the same. In that situation, by E cell, we calculate from the that is electrochemical cell. So E0 cell is calculated, and the feasibility of the reaction depends upon the Gibbs free energy change. If the Gibbs free energy change is negative, then the reaction will be feasible. And this Gibbs free energy change is equal to the W electrical, and this W electrical is equal to that is the charge and the EMF of the cell, and charge is equal to NF, that is and the EMF of the cell. So simply we say delta Z is equal to minus NFE cell. So that E cell and E0 cell will be taken. When E0 cell will be taken, then delta G naught, because when concentration of cell, then E cell becomes equal to E0 cell. And if delta G comes to be negative, then the reaction will be feasible. So this is the feasibility of the reaction that can be predicted with the help of the electrochemical series. Now, our today's topic, I want to discuss before you the Nernst equation, because when we take the galvanic shell, the concentration on both zinc sulfate and copper sulfate is 1. Now, what is the effect of temperature and the concentration on the EMF of a cell? That was quantitatively given by or observed by Nernst, and he put forward the equation known as Nernst equation. So this is a Nernst equation. Today's topic is Nernst equation for half cell. Half cell, right? So Nernst equation is always consider general m n plus equals, and this is Ne is equal to m, and this is solid. So E cell, or this is written half cell, or simply it is written as E half cell. Is half cell is equal to E naught m n plus oblique m minus RT by NF and log, and this is written as product by reactant. Product by reactant. Simply, this is the simplest thing, and this is this one. So we put it E naught cell Mn plus M minus, this is RT by NF and this is log. What is in the product side, that is M solid, and what is in the reactant side, this is M N plus aqueous. Step is very important to represent, to specify, or we say. Now, it is in the exponential form. If it is converted in the base 10, then Mn plus oblique M minus 2.303 RT by NF, and this is log LOZ, and this is written as 1 M N plus aqueous. This is the aqueous, right? So this is the E cell, right? That is half cell. For this is the general expression. Now, if we put the value in the question paper, the value is given. R is equal to 8.314 joule, Kelvin inverse, mole inverse, and F is approximately 96,500 coulomb. Then this is T is equal to 298 Kelvin, right? Then on putting this value, if we put this value, if on putting it, and on solution, need not to solve it, but because the value is already known, this comes equal to, that is E cell, that is half cell is equal to E0 Mn plus oblique M minus 0.059 by N, and log, this is 1 by M N plus across, because the active mass, this is the modified equation on putting the value. So the active mass of the solid here, that is M solid, or pure liquid or pure gas, is taken as 1. That's why this equation is obtained. So this is the Nernst equation for the half cell, right? So if the question asks calculate the value of the half cell of the, this is the half cell, now its application. Let us see its application. Let us see. Let us question is suppose Mg2 plus aqueous. This is twice electron, and here Mg solid. Given Mg2 plus aqueous is 0, Mg2 plus oblique Mg is equal to minus 2.36 volt. Mg plus ion concentration, 2 plus ion concentration aqueous, that is 0.01 m. Calculate E cell, means half cell. E cell means half cell. We have to calculate. How we calculate? This is Nernst equation, always written in the reduced form. So this is the reduced form. Now what is the equation? E cell we have to calculate. Then it is written as E0 Mg2 plus Mg, and this one directly we write here minus 0.059, and what is the value of here? That is N. N is equal to 2, and log, this is product. What is in the product? That is magnesium solid, and this is magnesium 2 plus aqueous, this one. So this magnesium concentration solid is equal to 1. So this is comes to be how much? Its value is given minus 2.36 minus 0.059. Now number of electron gained here. What is the number of electron gained here? That is 2. So we write here 2. And this is log, and this is solid. and this one is, what is the concentration? 0.01. So its value comes to be minus 2.36 minus 0.0295, and log, this is on solution 100, 2 log 10. So log 10 to the power 2. So there is a formula, log m per power n. So it comes to be n log m. So we put here minus 2.36 minus 0.0295 into 2 log 10 is equal to 1, and this value with unit, that is the whole. So this is the Nast equation applied in the case of half cell. This was the general, and this is a particular example by considering magnesium ion. Any metal ion can be considered to determine that is the half EMF of the half cell. Now, if we apply the Nast equation in the case of a complete cell, so we take this example also. So, another example for complete cell. For complete cell. Now we consider cell potential Nast equation for complete cell to calculate cell potential. So cell is, suppose zinc, solid, zinc 2 plus, and this one is copper 2 plus, aqueous, and this is copper solid, right? This is a cell. So now this question can be asked in another way. Suppose we have the question. Suppose E naught copper 2 plus copper given 0.34 volt. This value is given how much? 0.34 volt. And given E0 Zn 2 plus Zn. This is given 0.76 volt. This one volt. And the question, set a cell. Represent the cell. Question is, represent the cell. Write half cell and complete cell reaction. Complete cell reaction. Write half cell and complete cell reaction. Then calculate E cell. Given this is copper 2 plus, aqueous, concentration 0.01 m, and the Zn 2 plus aqueous concentration, this is 0.0001 m. So if the question is asked in such a way, then first we have to set a cell. So already I have set up a cell. How cell is set up? There is a simple trick. See, there is a, in the left, there is a, always in the left. So you write the value because it will erase it. It was, what is the value? 0.01 m. And what is the value of zinc? Aqueous, this will comes to be, this is 0.0001 m. This will be taken in use. So if cell I already, we have to calculate the EMF for that cell. But the question is twisted and asked in the another way, that if the E naught cell is given, then you will set a cell or represent a cell. Cell को represent करना है. How we will represent it cell? So in right there is always reduction. Right में क्या होता है? This is reduction. and in left always is oxidation. So we see the value. This zinc this is the electrode potential value, and if we study the electrochemical series, then I have told you the metals or the element which are the higher lower reduction potential value, more the tendency to lose electron and get oxidized. So here zinc will oxidize to zinc ion. This one always written aqueous, and this one is solid. And a higher reduction potential value, that it will have a tendency to take up electron and get reduced, because its reduced form is more stable. So copper 2 plus and copper, this is a solid and this is the aqueous. Now this is a half cell, this is a half cell, and this is also a half cell. Now how these half cells are connected? With the help of salt bridge, and the salt bridge is represented by that double line. So the question E0 is given, E0 is given, represent the cell, this is the cell representation. So you will keep one thing in mind in order to correct representation of the cell. If you will see that in the right side, always reduction will take place, means copper 2 ion, that is copper. And this complete cell is a redox reaction. So if it reduction takes place, obviously the other will act, in other electrode oxidation will take place. So this copper will have the higher value, so it is written on the right side. It is written in the right side in the reduced form. In the reduced form. And another, this is oxidation will take place, so it is always written in the oxidized form. So suppose here the half equation is written as per the question. So zinc, that will lose electron, Zn2 plus aqueous, and this is twice electron. Now this is right side, copper 2 plus aqueous, and this one is twice E, and this is equal to copper solid. So when we add the two electron, add the two half equation, then this is equation 1 and this is equation 2. And we have to see where the electron in both the equations are same or not. Suppose it is not same, then we multiply that half in order to equalize the number of electrons, right? If it is 3 and it is 2, then in order to make it 6, because 6 number will be common, so we should multiply here the 2, and so we should multiply a particular number. Now here is 2, here is 2, so there is no need to multiply the any number, the each half, right? So on adding, this 1 plus 2 is added, then it will give Zn solid, and this one copper 2 plus aqueous, and this one, this is copper, this is Zn 2 plus aqueous, and this is copper solid, this one. So the question is, in what is given, represent the cell, represented, right half cell, I have written half cell, and complete cell. If the two half are added, then it will give the complete cell reactions. Now, so for that cell, the cell reaction will be this. So we erase it and we write the complete cell reaction. This is the complete cell reaction. For this cell, the complete cell reaction is, suppose for your, to make it more easy, Zn2 plus twice E and copper 2 plus aqueous, and this is solid, so it comes to be what? This is 2 plus, this is equal to copper solid. Now we add, this is zinc solid, and this is copper 2 plus aqueous, and this is Zn2 plus aqueous, and this is plus copper solid. Now we have to apply the Nast equation. Nast equation for each half. So it can be written as as. Here the concentration we write here so many times it is 0.01 m and this is 0.001 m. So the direct equation can be, Nernst equation can be written for that cell. E cell, this is most easy. This is E0 cell minus 2.303 we write here. If you want to write it, 2.3 RT by NF and the log. This one is form is product and this is the form of reactant. REACTANT. Right? Now we put the value here. E0 cell, we have to calculate it. We have E0 cell minus 2.303 RT. Put the value on solution. If we put the value and solving it, that is 2.303 8.314, R is equal to and T 298 and N and this is the log 96,500 coulomb per mole. Then its value product C. This is the equation because we are applying the Nernst in the form of equation, not in the cell. If you will consider the cell in your brain and write the equation by keeping in the cell representation, then it will be wrong. Keep in mind the equation. So this is the product side and this is the reactant side. This is the reactant side. Right? So we can write here log product. The product, what is in the product? Zinc 2 plus aqueous and this is copper solid and this one is written zinc solid and this one is written as copper 2 plus aqueous. This is written like this. So on solving it, E0 cell minus 0.059 by N and this is log. Again copper solid and zinc solid, active mass is 1, so considered as Zn2 plus aqueous and this is copper 2 plus aqueous. Copper 2 plus aqueous. So you will see in the Nernst equation, zinc, that is product by reactant. There is no. If we consider the cell, that is in the Nernst cell representation, zinc will be in the left side and this copper will be in the right side. But if we consider the equation, then we are applying the Nernst equation. Always keep in your mind, we have to consider the inner form of equation. There is no chance of mistakes to solve the numericals. So now the question arises, how we will calculate the E cell, that is EMF of the cell, E0 cathode minus E0 anode. Now what is in the cathode? That is E0 copper 2 plus copper, and what is in the anode? E0 Zn2 plus Zn, because it is the reduction port form. Here oxidation will take place, but it is written standard reduction potential of right hand electrode and standard reduction potential in the right hand electrode, because in the electrochemical series the value is given in the reduced form. So E cell is calculated here. So if we put the value of this pole in that equation, we are able to calculate the EMF of the cell. This is the direct way. But in your book, how it proceeds, there is write the half cell for this one. He considered. So we also narrate it. Before narrating this, what will happen? What will be the effect on EMF of the cell? This is the cell potential of the cell. What will be effect on cell potential of the cell of the concentration of zinc ion and the concentration of copper ion? So what will happen? If the concentration of copper ion will increases, then what will happen? If the concentration of copper ion increases, then increases. If here is plus sign, then it will decreases, but it is with negative sign. So when you will increase the concentration of copper ion, then E cell will be increases, okay, because it is with negative sign. And what will happen if it will decreases? It will decreases. If here there was the positive sign, then it will decreases, but it is a negative sign. So when copper ion, zinc ion concentration decreases, that is E cell increases. So the cell potential of cell depends upon the concentration of zinc ion and as well as the copper ion, right? So we have the equation. So this is the direct way to use the Nernst equation, but it can be applied. So let us see by putting the concentration. By putting the concentration and by solving it. So what is here? E naught cell you calculated here, that is 0.34 volt and minus 0.76 volt. It comes to be 1.10 volt. You calculate it separately because there is a separate mass in calculating that. So you don't do the things directly. Now E cell is equal to, this is 1.10 volt minus 0.059. What is the value of n here? And here that will be 2, because we have seen that the number of electron lost is 2 and gained is 2. That's why here the value is 2 and log. And what is the concentration of zinc ion? So I have written here 0.001, and the concentration, when we put the small bracket after putting the value, when we put the value, this is 0.01. Now you will solve it. What will that it will be simply log 10. Log 10. This is 1.10 minus 0.059 by 2, and this one is log 1 per power 10. Is it clear? Now, so 10 to the power minus 1. It comes to be 10 to the power minus 1. 1.10 minus 0.0295 on dividing it, and log m per power n, this is 10 to the power minus 1, and log m to the power n, that is n log m. We can write it. So this is the way. So we can put 1.10 minus 0.0295 into minus 1 and to 1 itna volt on solving, we can get the cell potential of the cell. This is the direct way by using this cell potential of the cell, right? So we will calculate it. What done in your book, let you see how this expression is derived. How this expression is derived in your book. You don't confuse when you will see the book. And my method is just the direct I have applied it. How it will do it? This is copper 2 plus. Always it is written in the reduced form. Copper solid. Write half equation. E cell is equal to E0 copper 2 plus copper minus RT by NF log copper solid into copper 2 plus. So copper solid is always active mass taken as 1. So it can be written as E0 copper 2 plus copper minus RT by NF and log, this is 1 by copper 2 plus. Again, for another half cell, it is also written in reduced form. It is also written in reduced form. So this is written in reduced form, Zn2 plus twice E, that is equal to Zn solid, and this is always is aqueous, right? So we see E cell is equal to what we write? E0 Zn2 plus, and this is Zn or minus RT by NF, and this is log this one. This is Zn solid by Zn2 plus aqueous, right? Now, so what is that is E cell is equal to E0 right minus E0 right, E cathode minus E cathode, or this is minus E anode, right? So what is in the cell? This one. What is cathode? You write here E0 copper 2 plus copper minus RT by NF log, this one is here, that is 1 by copper 2 plus aqueous, right? So you will put in the bracket this one and minus. We put the another value here, that is E0 Zn2 plus Zn, and minus this minus put here is minus, so this minus and minus becomes equal to plus RT by NF and log 1 by Zn. So when we solve it, this and this will comes here, that is E, right? And on solving this, we come into the same equation as given in your book. So need not to write the each half. Directly we write the equation and we can solve the problem based on the Nernst equation. So this is very important topic. Today I want to finish this topic here, because the Nernst equation and how we able to write the half, how we represent the cell, how we are able to calculate the E cell, and what is done in the book I have also dictated. Both the way is the same. This is the simplest way. Directly by writing the equation we can do it. I hope sure that when you will calculate the E cell by on the solve the problem on the Nernst equation, you will get feel convenient to solve the problem. You will go through the book, and you will share this video more and like this video, so that it will encourage me to give the another lecture after that. That is for the different powers on the half cells. Suppose the Az and the copper and chromium and tin, like that we can discuss in another classes. That's okay, and have a nice day. Thank you.